Hey AAF students, welcome back. In this lesson, we are going to be using our knowledge of linear functions and transformations, right? That's what we spent the last 2 lessons on, right? A video lesson in class. I will define, graph, and analyze an absolute value function, right? And so we really tried to emphasize to y'all that transformations and thinking about linear functions in terms of transformations. And so we're building on that, right? So I really want you ideally to see the connection between a linear function and an absolute value function because they are closely related. And we're going to go ahead and we'll define what an absolute value function is, just like we did for a linear function. Maybe you know some background knowledge about what absolute value is. We'll talk about the graph of it and where that comes from, and then we'll look at it in terms of transformations, and we will analyze the result of it, and we'll analyze it from whether we're given the equation or we're given the graph, and we'll start that, and that will come more when we meet again in class, as it did with linear functions as well. So make sure that your notes are out and so that you are ready to follow along, and pause the video in various places to try things on your own. Don't be an active participant in this lesson. So my first task for everyone is to graph these 2 equations. I would say maybe pause the video and try this now. Hopefully you had an opportunity to try this. So what this is saying is I'm graphing the line y equals x with a restricted domain where x is greater than or equal to 0. So the first value I'm going to plug in is 0, right? So when I plug in 0, I get out 0. When I plug in 1, I get out 1. When I plug in 2, I get out 2. Right, that slope is 1, so it keeps going. So this is this graph. What about this? Y equals negative x when x is less than 0. So I'll start by plugging in 0. Negative 0 is just 0. So, oh wait, but that point's already there, so that's fine. Right, so it's just right here. When I plug in, well, I got to go less than negative 1. I get positive 1. When I plug in negative 2, I get positive 2. When I plug in negative 3, right, and so on, and it's going to be this decreasing line. Right? It decreases as you go from left to right. Boom, boom. Oh, I was close. This is an absolute value function. Right? So what we just did is known as a piecewise. Right? It has different pieces for different parts of the domain. It has different functions for different parts of the domain. So I told you to graph x, where x is greater than or equal to 0, and negative x, where x is less than 0. This piecewise function is known as an absolute value function. It has a special name because it's the most famous, or it's one of the most commonly used piecewise functions. An absolute value is a piecewise function. So the definition of an absolute value, this is what the graph of the parent absolute value function looks like. So this right here, your vertex, is what we're going to be transforming. Just like we transformed the center of a line, as silly as that sounded because the line goes on forever, we are going to be transforming this point, which is the vertex. Right? This one kind of has 2 slopes, right? It has a slope to the right of the vertex and a slope to the left of the vertex. So absolute value functions means the answer will always be positive. Oh, check that out. The answer, the output, that's not how you spell output, will always be positive. The whole thing happens above the x-axis. Right? Think about when's the only time it would happen below. Maybe if it reflected and it was opening down instead. Maybe if it was translated down, right? But the output of what's inside the absolute value will always be positive, right? So think about absolute value. It is distance from 0. Distance is always positive. I'm not like, not that I drive to school, but like when I drive to school, maybe I'm driving 2 miles there, When I'm driving home, I'm not like, I'm going -2 miles. Like, I'm still going 2 miles. Distance is positive. It doesn't matter which direction you're going in. So it's the distance that something is from 0. Right? So it is a function. Is its inverse a function? No, it's not one-to-one, right? So absolute value function, this is what it looks like. It has an x-intercept. It has that vertex. The graphing form of the equation of an absolute value function looks like this, right? I'm going to start it off and it's going to look pretty similar to when we dealt with a linear function. These two right here are going to be the x-coordinate and the y-coordinate of your center point, of your vertex. So I'm going to refer to them as h and k. This right here is going to be the slope to the right of your center, A. Right? So there's another slope, right? That's why I'm saying the slope to the right of the center point. This is the slope to the right. I would certainly hope that you will at some point, if you don't recognize right now, if this slope was 2, this slope is -2. Right? So my slopes, if I'm going to like pluralize that, would just be plus and minus 2. Right? So the slope to the left of it, of the center point, is going to be the opposite sign. The vertex is 0, 0 right now. Let's look at this. So if we're going to graph this, I know we just did this several times, graph the normal, right? Sometimes called the parent function. This is what we're going to transform from. So my vertex is at 0, 0. My slope to the right is 1. My slope to the left is -1. My transformations, right now there's none. That point 0, 0 is still at 0, 0. We're looking at the transformations of this specific point, right? And what's happening. And that's like the center point. So I've got 0, 0, the slope to the right. I'll do 2 of them. I'll do a few of them. That was interesting. I'm just emphasizing the importance of the parent function. Right? Like our parent function for a linear equation was y equals x. This is our y equals the absolute value of x is the one here. What about if we're looking at, so the y-intercept? We can see it, but the y-intercept is where x equals 0. So really it's y equals, algebraically, y equals the absolute value of 0, which is 0. So my y-intercept is at 0, 0. What about the x-intercept or x-intercepts, right? I could have up to 2. I could have 2, 1, or none. You're going to have one y-intercept. The vertex will not always be on the y-intercept. The x-intercepts are going to be where the equation equals 0. Well, where the absolute value of x equals 0. Well, the only thing I could put in there would be x equals 0, so it's at the point 0, 0, which we see graphically. Right, so let's label some points. 0, 0, and I'll pick a point over here. I'll say 3, 3. And it's reflection point, right? It reflects over that line, -3, 3. I'll get in the habit of labeling. Let's look at this one here, right? I say maybe watch this one, and when I put this one up for y'all, you guys should pause the video and try it. So for this one, my vertex has now moved, right? I'm looking at like HK. Well, my vertex is going to be at 1, 5. It was y minus k. My slope to the right is going to be right here. It's going to be -2. My slope to the left is going to be +2. My transformations, this is going to, it's going to do a few things. That negative is going to make it reflect over the x-axis. That 2 is going to make it, it's going to become steeper, right? We can think about it like that. We did this with linear equations, right? But I'm going to refer to it as a vertical stretch to get more fancy by 2. And then it's going to go right 1 and up 5. Right? I think it's important to recognize all of that. The point 0, 0 is now at 1, 5. Let's sketch this. So I'm going to go to 1, 2, 1, 2, 3, 4, 5. 1, 5. To get the slope to the right, I'm going to go down 2, right 1. Down 2, right 1. Right? And then down 2, left 1. Down 2, left 1. Not my greatest graph. So I can see that there's definitely 2 x-intercepts. And I can see the y-intercept, right? So this is the point 1, 5. Maybe I'm going to label this as 3, 1. And this point right here is negative 1, 1. Get in the habit. This is my line of symmetry. X equals 1. That's a good one to think about, right? Line of symmetry is that x equals 1. What about the y-intercept, right? I can see it. I know that it's at 0, 3. How algebraically would we figure that out? Well, we would plug in 0. Y minus 5 equals negative 2, 0 minus 1. Absolute value of 0 minus 1. Y minus 5 equals, well, negative 2. 0 minus 1 is negative 1. The absolute value of negative 1 is 1. That's how I get rid of those absolute values. Sign. Y minus 5 equals negative 2. I'll go ahead and add 5, and I'll get 3. And that's where I'm getting that point 0, 3 algebraically. For the x-intercepts, I know there's 2, but they're harder to see. Oh, I'm not giving myself much room. It's okay. I'm going to use a different color so y'all can see where I'm going with this. So the x-intercept is going to be where I'm going to plug in 0 for y. I'm going to actually go up here, so hopefully you guys are okay with this. 0 minus 5 equals to negative 2, and this can get tricky, so I would really suggest don't just assume you're like, I know algebra. This gets confusing. We're not going to distribute into this absolute value symbol. We don't want to do that. Think about, like, there's something I can't break into. There's something I can't. Okay? It gets really messy if you're going to try to do that. Negative 5 equals negative 2. My pen is having some issues. X minus 1. I'm going to go ahead and divide by negative 2. And I'm going to say 5, right? Negative divided by a negative. I have 5 halves. It's like a dead spot on my screen. Equals the absolute value of x minus 1. So I really want you to think now. If I said the output of an absolute value was 3, I could have been taking the absolute value of 3 or negative 3, right? So really what you have here is I can break this off into 2. And I can say x minus 1 is either going to equal to 5 halves or it's going to equal to negative 5 halves. Add 1 and I get 7 halves. So that's one of them. Add 1 as well over here, and I'm going to get negative 3 halves. So my 2 x-intercepts, I apologize, this got pretty messy for me, are 5 halves, 0, nope, 7 halves, 0, and negative 3 halves, 0. Right? Algebraically, they might have been a little bit hard for me to see and truly know by staring at it like that. So it was important that I learn how to do it algebraically. So just to reiterate over here, I'm not distributing into an absolute value. That is not what I'm doing. What I am doing is I am isolating the absolute value and then splitting it off into 2 because what was inside that absolute value could have been positive or negative, right? Like if I take the absolute value of 3 and the absolute value of negative 3, I get the same output. And that's why this isn't 1-to-1, right? That's why it bounces back. So I'm going to give you one that's similar but slightly different. And I'm going to ask you to do the exact same thing I just did, with this one. And so what I would really like to happen right now is that you pause the video and you try it and you identify any places where you lack some confidence with this and where you feel pretty strongly so that you know where you are right now. So hopefully you've done that and used mine as a model. So the vertex here would as well be 1, 5. But the slope to the right is now going to be 2, and the slope to the left is going to be -2. The transformations are, this will be a vertical stretch. It's going to increase, right? It gets narrower, is another way to think about it. A vertical stretch by 2, and it goes right 1, it translates right 1, and up 5. The 0.00, just like it was before, is now the 0.15. I'm going to go ahead and sketch it up here just like I did. Right? And sketch and label, just to emphasize. So I'm going to go to the point 1, 1, 2, 3, 4, 5. But I'm going to go up to right 1. This is 1, 5. Up to right 1, I'm sorry, up to right 1 would be 2, 7. And then up to left 1 is going to be 0, 7. And I get something like this. So we know right away that what the x and y intercepts are, right? Like I can look at this and use my common sense to know that my y-intercept is 7 and my x-intercepts, there aren't any, right? But let's go ahead and let's still look at it algebraically. Because what if I wasn't asking you guys to graph and I wanted you to show me algebraically or analytically, right? That could so happen. I'm going to go ahead and plug in 0. Y minus 5 equals 2 times 0 minus 1. So y minus 5 equals, well, 2. This is just going to be 1, so 2. So I get y equals 7. So my y-intercept is at 0.07, which I knew, right? It's good to use my knowledge. For my x-intercepts, we know we shouldn't get any. So let's see what happens when what that looks like algebraically. I'm going to plug in 0 for y. 0 minus 5 equals 2 times the absolute value of x minus 1. So this is going to be a -5. Remember, we're not distributing into that absolute value. Don't do that. Divide by 2, -5/2 equals the absolute value of x minus 1. What? I can't split this off now. It's absolute value. We just defined absolute value as always positive. It is distance, right? I just talked about how I'm not going to drive home and go -3 miles. Come on now, right? This is not possible. This right here is where we algebraically get stuck. This tells us when I get an absolute, oh my gosh, my pen. When I get an absolute value symbol, and it says that the absolute value is negative, that's where it's not possible, right? So that's where I know algebraically that there are none, right? And I know I certainly hope that you all aren't just doing this and being like, I see that there's none. I want you to use that knowledge and understand what that looks like algebraically and make that connection, I think is very important. So hopefully you've made some notes as to like where you might need to ask questions or what you're like, oh yeah, I got that now. We did the y-intercept and the x-intercept. We graphed these, right? I graphed them. So I'm going to close up with this one right here. And I want to talk a little bit more about characteristics for some of you guys that are like, I got this, I'm good. So how are you doing? Y minus 1 equals -5, 6, x plus 4. You know what? If you're confident, go for this. Try it. See what you can fill in here. My vertex is going to be -4, +1. right? My slope to the right is going to be negative 5/6. My slope to the left is going to be positive 5/6. That 0.00 is now going to be at negative 4,1. I am going to have reflected over the x-axis I'm going to be, this is going to be wider, right? Which is known as a vertical shrink, right? It's going to get wider because that's less than 1, 5/6. And then it's going to go right. Nope, it's not. Left 4 and up 1. So left 4 and up 1. My slope to the right is going to be negative 5/6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I'm going to go off a little bit here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I'm off a little bit, but that's okay. Let's label. What is this? Negative 4, 1. This is 2, 1, 2, 3, 4. Negative 4. And what would this be? So I'm going to the right 6, right? So left 6, this is going to be negative 10, negative 4. I got that negative 10. I mean, you can count, but if I'm subtracting 6 from the x value, I just did negative 4 minus 6. So I can tell that there is an x-intercept, two x-intercepts, and there is a y-intercept. I'm not going to go based off how I graphed it. I mean, I'm more or less probably in the vicinity, but it's not going to be perfect. So my y-intercept, I'm going to go ahead and plug in 0. Y minus 1 equals negative 5/6, 0 plus 4. Y minus 1 equals negative 5/6 times 4, right? Let's see, I'm going to go up here a little bit. Y equals, what is this? Negative 20 over 6 is negative 10/3, right? I just multiplied straight across. And then plus 1, or I'll add 3/3. Please don't pick up a calculator, my friends. This is non-calculator stuff. Negative 10/3 plus 3/3, right? That's just 1. I can express 1 as, it can be 3 over 3 is 1. That'll be negative 7/3. So my y-intercept is 0, negative 7/3. That's the point. So that's probably around, I mean, that's a little bit more than 6. I'm sorry, that's a little bit more than 2. So I'm about there, right? A little bit more than 2. Pretty good. And then the x-intercepts, I'm going to go ahead and plug in 0 for y. 0 minus 1 equals, and I should get 2. So if I mess up, and I get something that doesn't make sense, then I know that I messed up. Instead of dividing by negative 5/6, I'm going to multiply by negative 6/5, right? Multiply by the reciprocal. So I'm going to have negative 1 times negative 6/5, which is just 6/5, equals the absolute value of x plus 4. And this is where x plus 4 could have either, like what's inside here could either be 6/5 or it could be negative 6/5. And I'll go ahead and subtract 4, which is like subtracting 20 over 5. Right, 20 over 5 is the same thing as 4. And I'll do that as here as well. If my pen wants me to. 6 minus 20. What do I get for that? I think 20 minus 6, then it's the negative. Negative 14/5. That's a little bit less than 3. Oh, that makes sense. That's probably right about here. And then my other one is 6 minus 20 is, no, negative 6 minus 20 is negative 26/5, which is probably a little bit more than 5. 1, 2, 3, 4, 5. Yep, right, I'm about there. So my two x-intercepts are going to be negative 14/5, 0, and negative 26/5, 0. Fractions, my friends. not decimals. So if you're feeling good about this, maybe think through some characteristics. So some things that, and even if you're like, I think I get this, but let me see what's coming. Think through things like domain. Do you know what the domain of this is? Do you know what the range of this is? Do you know how you could do that from the equation before you even see the graph, right? Can you make some connections there? What about increasing and decreasing intervals? My pen's like not letting me write. In a linear function, it was either just increasing or decreasing over the entire domain. Is this one, right? We're reading from left to right. We did the x-intercept and the y-intercept. We did that. What about line of symmetry? How do you know that from the equation? Right? You're looking at the graph, but make the connection between well, how could I do this without even looking at the graph? Right? So that I can do this algebraically and analytically. I'm personally a very visual person, but to be able to use the graph to help myself make connections to later apply is a very valuable skill. So if you're ready and you want to think through some of these things, this is where we're going with it. And I do think that would be very useful to you all. But in this lesson, we had an introduction to absolute value functions and defining it, looking at the parent function, looking at some transformations to see what the results are. I think a big one on this that might be a little different is the x and y intercepts and using them, not just looking at them graphically, but understanding how to solve for them algebraically. So you guys have a post-lesson check-in that involves linear functions and absolute value functions. You have unlimited tries. What I would do is review a little bit, make sure that this is something you get, and then go and try it and see what your results are and see if it's something that you want to redo and try again and see where your shortcomings with this topic may be. So other than that, we will see you next time where we will work together more on absolute value functions. Thanks for watching.